So first thing is recognition. Is question 1 recursive or explicit? Recursive, good. And so we know the first term is going to be who? 4. And the second term and all terms after are going to be equals what? Just read it. N. And where is N? Over here, right? And then what? Plus the term before it, which is up here. Is that right? Enter. Then if I grab that and drag it down, we have our terms. Okay, question 2, is this explicit or recursive? Explicit. So all we have to do is do equals 3, and I'm not sure if the spreadsheet understands just parentheses as multiplication. So I'm going to make sure it knows what I'm doing. So I'm going to do shift for multiplication, and then I'm going to do parentheses -3, close parentheses. How do I do exponent? Caret. And who's my exponent going to be? The n, right? Which is w in this case, but the position. Is that right? If it depends only on the position, it's explicit. Enter. Drag that down. There we go. Last one, is this recursive or explicit? Good, recursive, that's right. To get the next terms, I have to know the terms before it, don't I? So 1, 2, 3. Those I'm just given, right? That's who they are. I just type them in. There's no formula there. If I go to formulas, and show the formulas, the 1, 2, 3 aren't going to be formulas, right? Okay, now, for the fourth position, equals, who am I going to add? The term before it, plus the term before that, plus the term before that. And as I change positions and go up 3 terms, it'll pick the correct ones, won't it? So I press enter. Boom. Let's see what happens. I'm just drag it down once. It takes D5, D4, D3, the 3 terms before it, right? And so, voila. Ooh la la. All right, so here, first 4 terms, I plug in 1, I get 4, is that correct? Now terms for a sequence, what do I put next? Comma or plus? Comma. This is a sequence only. If it was a series, then I would add them. Words are important. Let's get those straight. Plug in 2 squared 9. Plug in 3 squared 16. Plug in 4 squared 25. Okay? You do the other 3. All right, so who's the first term for B? -5. Second term? -3. Third term? Fourth term? Wait, who said that? No, don't listen to you anymore. What is it? 0. And then what? 4. Okay? And then here, stay with me. Did you give me the 4 numbers? What were they? 5 plus 7 plus 9 plus 11. And what did you get? 32? And here we have, so 32, 64, 128, 256. And because it said evaluate, find the value, that means you have to add them, right? If it said expand or rewrite, you'd be done now, right? Anyway, did you get the answer for this? 480. Now, do we go with a consensus in math? No. We go with the right answer. I don't care if all of you agree on it. If it's wrong, it's still wrong, right? But the hope is you're good enough to get the right answer. All right, let's move on. Now, it would be nice if we had some formulas for this and not just list all the numbers and add them by hand, right? So we're going to talk about a category of sequences that have special properties. That category is an arithmetic sequence. Weird pronunciation. I know. That looks like arithmetic, doesn't it? But arithmetic is pronounced that way when it's a noun. But this is the kind of sequence, right? So this is an adjective, arithmetic. Weird. The English language is so weird. Same spelling, but different pronunciation depending on part of speech. What word is this? That's lead if it's a verb, or that thing in your pencil is lead if it's a noun. Oh, yeah. Weird, huh? What's that? Read or read, depending on present tense or past tense or something like that, right? Anyway, let's move on. So these special kinds of sequences do the following. How much from here to here? From here to here. From here to here. So they are equally spaced. Sometimes called a common what? Difference. Wait a second. What does the word difference mean? Subtraction. 12 minus 8. 4. 16 minus 12. 4. 20 minus 16. 4. Now let's use the notation we used earlier. What is this? That's some position. Subtract. What's that? The difference is coming. Who's this? The previous term. Perfect. And in this case, any term minus the previous term is 4, right? In general, it's going to be the common difference. All right? Is this arithmetic? What's the difference this time? 2.5 isn't bad, but it's going down. Negative. How do you know? This idea here. You take any term and subtract the previous term. Aren't you going to get a negative? That's the way to tell. That's the way to tell. Is that arithmetic? Am I adding 1 each time? Well, yeah, I'm adding 1 to the tops by themselves, adding 1 to the bottoms by themselves, but I'm not adding the number 1 from this fraction to this fraction, am I? So I'll bet you this is not arithmetic. So clearly, the first term is 6, and if the common difference is 4, what's the next term? 10, so that if I were to take this number minus that number, I get 4. Remember, subtract backwards. I can see why you'd say 2. It's a good mistake to make now, but as time goes on, you'll see the difference, okay? Next term. 14, next term. 18, very good. Now, first term is 3, but this time, who's the next term? 1, and then? And then? So if the d value is positive, the sequence is going to increase, isn't it? If the d value is negative, the sequence is going to decrease, isn't it? So then if I put the second term is 12 and the third term is 20, who is the d value? 8. What's the next term up? What's the next term back? Good. Now, what if I give you this and I say keep going and give me the 100th term? You would scream at me, wouldn't you? Or, let's think. Who is the first term? 4. Who is the second term? What did you do? Add 3. Who is the third term? 10. What did you do? Add 3. This is the first term. This is the second term. This is the third term. So you have, who's this? First term. Who's this? It's the second term, right? Who's this? Third term. Who's this? Which term? But I've only added 3 3s. But I'm at the fourth term. How come they don't match? Because when I start at the first term, I don't do anything to get to the first term, don't I? So, the 100th term, I start at 4, and I add a bunch of 3s, don't I? If I get to the 100th term, how many 3s am I going to add? Good. And I'm going to write it like this. Right? It's like in the backyard if you have stepping stones. You stand on the first stepping stone, you're not going anywhere yet, right? You move to the second stepping stone, you've taken how many steps? 1. I go to the third stepping stone, I've now taken how many steps? 2. The stepping stones and the steps don't match. Cute little story. Did I tell you this yesterday? My daughters asked me when their birthday was. And I said in 3 days, or whatever I told them. And then they asked me this question, which made this math teacher so proud. Is today 0 or 1? Right? It's like, how do I count? And I go, that's so cool. Anyway, so then let's take this idea and make it a formula. Who is 4? Term 1. How about that? Right? Plus, what's 100? Where the last term is. Isn't that n? The position. And then minus 1 is minus 1. And what's 3? The difference, good. And what is this going to give me? A sub n, the position I'm looking for. Now, do you understand this? So here's what's going to happen. I'm not going to give you this. Because you understand it, right? You can come up with that yourself. This is not going to be just memorizing a formula and plugging in. This should make sense. Math should make sense. If math is just formulas and plugging in, it's not making sense, right? How often are you going to use a formula and plug in life? Very rarely. How often are you going to have life make sense? Much more often. You're going to think, I hope. Okay? So, that's what this is all about. How should you write the explicit formula? It's right here. But you don't have to memorize it because it makes sense, right? Where do you always start? First term. How far do you step each time? D. And how many steps do you take? One less than the term you're looking for. One less. Makes perfect sense, right? Okay, so boom. Go ahead and do 1 and 2. So they want you to find a sub n. So a sub n, any term is, I always start where? First term, and I add a bunch of d's. How many d's do I add? N minus one of them, right? The number of steps is always one less than the stepping stone I'm stepping on. And then we know the first term is 8. And they want us to talk about the 8th term. And the d value is 5. And so that's 7 times 5 is 35, plus 8 is outstanding. Same thing here, a sub n equals a sub 1, first term, 1 less step than the stepping stone I'm stepping on. First term is 4. I'm looking for the 8th term again. Now, if I do this, I'm warning you, I'm going to take off. Because what is that? Subtraction. What's this? Multiplication. Do you see the difference? Okay, you've been warned. Be careful. So we have 4 plus, see, 7 times negative 5 is negative 35. And what'd you get? Negative 31, is that right? Okay, good. Okay, now, the next ones are a little different. We're not going to be able to do all of them, but they're all the same. So let me just do 3. So let's take this. So I'm going to take this. A sub n is always the first term plus one less step than the stepping stone. And then I'm going to do, let's do this, let's color code this. So this one's going to be red. Who is the 5th term? 4 goes here. Who is the first term? We don't know. Which term is 4? The 5th term. 5 goes here. The difference between the term and the position, right? But we've been doing that. I think you're used to that now. We also don't know D, do we? Then in green, we'll do this one. Who is the 11th term? 22. Who is the first term? We don't know. 22 is the 11th term. All right? Now here's the green equation cleaned up a bit. And here is the red equation cleaned up a little bit. Does this remind you of something from Algebra 1? Systems, canceling out, elimination method. What if I subtract the red from the green? The good news is, who disappears? A1. That's good, because right now I have two variables, two equations. That's too much. But if I subtract, what do I get? 18 equals, the a sub 1's are gone, and I get 6D. Solving a system of equations. And then D is 3. Who's left to find? A1. How do I do that? Plug it into either one. I'd pick the red because it's smaller. So then 4 equals, I don't know the first term, 4, but I know who D is now. D is 3. So a sub 1 is going to be, is that negative 8? Okay. But now, we're not done yet, because back up here we have to find what? The 8th term. Well, sorry, we have like no room. I'll squeeze it here. The 8th term is what? Where do I always start? The first term, who is it? Who is it? Negative 8 plus, if I want to get to the 8th term, 8 minus 1, which is 7, you're right. And how big are my steps? 3. Will that get us to the 8th term? Yeah. And so do you see all of these are like that? They're going to give you 2 terms, but they're not the first term. But you can come up with a blue equation, sorry, a green equation and a red equation. And then 6, let's do that real quick. Who is that? Second term. So if D is negative 3, I go negative 3 if I go this way. What do I do if I go this way? Plus 3, right? And so it's going to be y plus 4. Does that make sense? As the first term. And then to get to the 8th term, I take the first term plus 8 minus 1, and then I take the D value they gave me, and it's a little bit of algebra to clean that up. All right?